Hello everybody. This is going to be a presentation on Tizen. It will be an introduction, so it shouldn't go into many details. So my name is Carsten. I am often known by the pseudonym Rasta or Rastaman. I am a principal engineer at Samsung Electronics in Korea, and I have been working on Tizen now for several years. I have also founded open source projects of my own, several of them. The most well known is probably Enlightenment, a window manager, and now also Toolkit. I mostly look after the graphics subsystem in Tizen, where I give input on it and actually look at code, review stuff, etc., etc. So what is an operating system? Tizen is certainly one of these. Operating systems control the lower level of your hardware. They sit between higher level processors and the actual drivers and other infrastructure that lets you access the hardware on a particular device. It allows more than one process to have access to this hardware and may enforce security and other access rules and policies. There are several examples of operating systems today. Windows is one of the most widely known. Linux is another. There's BSD and QNX. You might notice that at this level, we are really talking about the lower level parts of the operating system or kernels. Modern operating systems also provide much more than just the low-level kernel. They provide display systems. They provide entire desktop environments. You've got the Windows Explorer environment with its file manager, taskbars, etc. You have the Mac OS X desktop environment, and on Linux there are several that compete as well for that. They often today also come with web browsers. They come with file managers so people can access, open, and otherwise manage their files with a graphical user interface. They come with basic configuration tools for the operating system, from things like configuring your displays through to your network and so on. They come with debugging tools for developers at times and other system management tools like user management, etc. Of today's modern operating systems that people know, the actual core kernel is only about 5 to 10% of the operating system. Most of the operating system is living above the kernel, and often this is termed middleware. Many operating systems that people know often share kernels. If you've heard of Ubuntu, Fedora, Red Hat, SUSE, etc., they all share the same Linux kernel, as does, for example, Android. The BSDs all share a BSD kernel, and that includes actually Mac OS X or 10 as well. They often come from different backgrounds and histories. Some have been created by companies as products, others have just grown organically by developers putting them together as they need. What most people today refer to as an operating system, like Android, iOS, Mac OS X, Windows, or your Linux distributions, is a combination of hundreds of pieces of software that work together to provide you with your basic operating system. So some of the combinations we have today that use a Linux kernel would be Tizen, Android, Ubuntu, and Red Hat, for example. The BSDs would be FreeBSD, iOS, and Mac OS X. There is QNX, which is the core of BlackBerry's OS version 10, and there's the Windows NT kernel, which powers Windows XP and newer. So there is often a lot of confusion as to what Linux really is. A lot of people will say Android is Linux, Tizen is Linux, Ubuntu is all Linux, and thus they must all obviously be the same. In fact, they are not the same. They are very, very, very different. For example, in Android, the kernel might be the same or very similar to the same one that comes in both Tizen and Ubuntu. But everything above the kernel is very much different. It's a very different user space. Ubuntu and Tizen are in fact much closer cousins than either are to Android. So I've really covered this to help address the confusion that Tizen and Android might in fact be almost exactly the same operating system because they share the kernel. One of the advantages of Tizen for people who are familiar to normal Linux systems like servers, other desktop distributions, etc., is that Tizen is far more familiar for these people. So if you wish to get to know Tizen, if you already don't know what a regular Linux distribution looks like, maybe you should try one. This would be a good first step to understand what Tizen looks like. As looking at Android will not help you a lot in this regard. And of course, it is very, very different to iOS, OS X, and Windows. Between the regular Linux distributions and Tizen, you will find the shell, your development environment, most of the libraries, and your display system to be very, very similar. Current Tizen 2 releases actually use the same display system, X11, that your regular desktop Linux distribution would. And Tizen 3 now supports both Wayland and X11. You can, in fact, download existing snapshot images for Tizen 3 that may boot on a regular Intel x86 device, but beware that the driver support will not be as complete as a regular distribution. So it may or may not work for you. So what is inside Tizen itself? Well, as I was saying, it is really a regular Linux distribution in most respects. There is, of course, a Linux kernel. It has a glibc or eglibc base system, a BusyBox shell, and BusyBox is simply something that provides all your standard Unix utilities like ls, tar, rm, mv, etc. The security in the kernel is implemented using SMAC, which is in fact something that you don't find on regular Linux distributions. Our IPC system at the core is really dbus, which is the same you find on normal Linux systems. The display systems today are both X11 and Wayland, with Tizen 2 supporting Wayland in IVI, and from Tizen 3 in Core Common as well. The communication subsystem that configures your Wi-Fi, handles your Bluetooth, etc. is Conman and Bluesy. We use GCC for our SDK and development for compiling. We use Cairo for rendering vector graphics. We use GStreamer for video. Pulse Audio handles audio policies, mixing and routing. OpenSSL is used for encryption. SQLite is used for database storage. Our core system uses RPMs for packages. The compositor and window manager for most profiles is actually Enlightenment. Western is currently used for IVI. EFL, the Enlightenment Core Toolkit, is in fact used on all profiles except IVI at this stage. It is optional on IVI. DALI as a 3D toolkit is coming in Tizen 3 and is already in the repositories. There are also lots of core C library APIs to access sensors, location, and many other aspects of Tizen. We use WebKit in Tizen 2 for the browser engine and web runtime. As of Tizen 3, we have chosen to follow the Blink fork of WebKit, and we have a fork of that called Crosswalk, and Crosswalk provides the web runtime and is also used for building the base browser engine for Tizen 3. All our HTML5 support for application development follows all the latest W3C standards, and we add Tizen APIs where and if needed to extend that. Tizen supports many variations of the core operating system. Mobile is one of them, IVI for vehicles. There's TV, wearables, and as of Tizen 3, we now also have Common, which is meant to be a simple common profile from which everything else is built. That is, in and of itself, may be generically useful to people, but isn't really intended for specific products. So what is a profile? A profile in the Tizen world is a variation of Tizen specifically targeted to a certain kind of product market segment. So IVI may have very different needs from mobile, may indeed have different needs from TV, for example. Most profiles share some amount between them. At the moment in Tizen 2, they are relatively distinct, that they have their own development paths, but as of Tizen 3, with Tizen Common, they will share a lot more. Amongst the profiles these days, mobile, TV, and wearables are all X11 based in Tizen 2. Tizen 3, this will support both Wayland and X11. So currently in Tizen, we have two major lines of work. There is Tizen 2, which is continuing to have releases. There has been Tizen 2, 2.1, 2.2, and 2.3 is currently being worked on. The last stable release of Tizen 2 is in fact 2.2, and there currently has been no release of Tizen 3, so 2.2 is in fact the latest stable release. Currently, Tizen 2 development is being done behind closed doors, and Tizen 2.3 will be released when that development is done. But right now, none of those details have actually been made public as to what Tizen 2.3 has in it. Tizen 3 is being worked on in parallel. All of this development is done in public. You can look at review.tizen.org to see the Git repositories. All the bug submissions and all the reviews are also done in public on Tizen.org domains. Also, as of Tizen 3, we're doing much more work in upstream projects than in the actual Tizen repositories. So if you actually look carefully, you might find a lot of work is going into the relevant upstream projects that is then later fed into the Tizen 3 repositories, as opposed to being done separately in Tizen's own repositories. Currently, with Tizen, the shipping products you can get today are all either Tizen 2 or Tizen 1 based. And yes, Tizen 1 products actually existed. The Samsung NX300 was actually a Tizen 1 product, but you couldn't write applications for it. So currently, if you want a Tizen device, the Samsung NX300M, NX300, and NX30 do run Tizen. The Samsung Gear 2 and Gear 2 Neo also run Tizen, and you can develop apps for them using HTML5. The Samsung Galaxy Gear, the original Gear Watch, also has a Tizen firmware update that makes the Gear 1 also run Tizen as well. So why Tizen? Different platforms are intended for different purposes. For mobile, we have Android iOS. There's BlackBerry's OS and also Windows Phone, not to mention a few others as well, maybe like Jollers, Sailfish, etc. On PCs, Windows has the lion's share of the market, along with OS X and Linux rounding the rest out, and some BSDs here and there as well. On the server, Linux has mostly replaced all the Unixes that used to be there, but they still are there. There is also Windows and BSD on the server side. But Tizen is actually intended to cater to more than one of these market segments. It isn't just mobile or just PC or just server. It is meant to do a lot more. So why Tizen? Tizen starts from a full desktop and server platform, which we already have from a normal GNU Linux distribution. We add and remove features in each profile accordingly to make sure that we can meet the needs of that profile, whether it be mobile, IVI, TV, or anything else. We choose a lot of high-quality software, either from open source projects or build it ourselves and make these projects also open source. We do a lot of testing on Tizen and on the individual projects that make up Tizen. There's a lot of infrastructure that we inherit from Linux that helps for both system developers and for platform and application developers. And by doing this, we don't need to reinvent a new platform for each and every profile or market vertical domain. We add HTML5 support to Tizen. That means anyone with existing web development skills in HTML5 can now develop applications very, very easily. We reuse existing web engines like WebKit and Blink in order to have complete full standards compliant support. We have some of the best HTML5 support in existence. We actually rank amongst the highest numbers in terms of HTML5 test support compared to almost any browser out there. And by doing this, we again don't need to reinvent any wheels. Tizen itself is backed by some very, very big names. Samsung, Intel, Panasonic, NEC, Huawei, Vodafone, Orange, NTT Docomo, SK Telecom, Sprint. If you go and look at the Tizen Association, there's even more listed there than this. There are many industry partners backing and supporting Tizen. There's a lot of investment going on. And that is why Tizen has a future. Because Tizen is open source, we are not hiding anything from you. You can see it, know how it works, even contribute back. You can modify it as needed. Anyone who wants to make a new profile for a class of Zeiss could do it on their own. You don't need official support to do that. Anyone can do it. That is the nature of open source. You don't have to sign any contracts to get access to Tizen. You don't just get a small open core and then have to sign away your life for everything else. Tizen is all open source. You don't have to sign up for anything. Now, if the same OS, Tizen, were to run everywhere, you now spend less effort porting software from platform to platform. Your users have to adapt less from platform to platform, and they have a much more consistent experience. So why don't you join us into creating, using, and making products with Tizen? It has an open development model. Even though Tizen 1 and 2 had closed development models, 3 already has an adopted open development model. All changes to Tizen are public. You don't get any nasty surprises, no code dumps. You know what's coming before it's there. You see it as it happens. You can submit patches via Gerrit. You can report bugs via Jira. Just go to tizen.org and you'll get all the links you need. So thank you very much. I hope you have gotten a lot of useful information out of this presentation, and I hope to see you again. Thank you.